x. So a lot of these problems will be pertaining, since we're doing cubic functions, volume. So the volume of a rectangular prism, you multiply the length by the width, so like the base, and then you multiply by the height, which would be how many little like rectangles you would stack on top of each other to make a three-dimensional figure. So if you don't know this formula, you will want to memorize it. In geometry, those of you that haven't taken it or are currently taking it, we do learn it, but not until later in the year for volume. So this one says, and they're all a little bit different. I know how much you love word problems. Several popular models of carry-on luggage have a length 10 inches greater than their depth. So the length is 10 inches greater than their depth. To comply with airline regulations, the sum, that's a key word, of the length, width, and depth may not exceed 40 inches. Okay, so it can't exceed it, but we're going to assume that the sum of them will be exactly 40. Okay, so we're going to assume length plus width plus, instead of depth, they're calling it, instead of height, they're calling it depth, is 40 inches. Graph the function relating volume to depth. Find the x-intercepts and what do they represent. All right, so we need to come up with representations for length, width, and depth. Variable expressions. They actually tell us one of them already. The depth is x. Now we need to come up with other representations that include x, that would be length and width. So who thinks they have one? Augie.
For length, wouldn't be x plus
Good.
10?
The length is 10 inches greater than the depth. So x plus 10, that's the easy one. How do we figure out what the width is? Remember that they told us the sum of the length, width, and depth has to equal 40. Jax?
Well, you went through the equation, right? Didn't you have to?
Yeah, you can.
It would be x plus 10
X plus 10.
plus x plus y.
Okay, well, width we don't know.
Yeah, so it'd be like,
So leave that as like, let's just leave it W, or you could put Y, that's fine. But the depth is X.
and then it would be less than or equal to 40.
They told us to assume that it is exactly 40, because we want to like maximize the volume. Equals 40. Augie?
And you then just subtract the x, and then subtract the equation, and then just solve for W.
Yes, solve this out for W. You can either combine like terms first and then subtract, or you can just subtract. Abby?
What does the parentheses say?
X plus 10. And I got that from up here, where we had the length was X plus 10. The width we don't know, so I'm leaving it W. And the depth was X.
So w would equal.
So it's, again, it's up to you if you want to combine like terms first. 2x plus 10 plus W equals 40. And then we have to subtract 2x and subtract 10.
Please excuse this interruption. Ninth grade boys basketball is dismissed at this time.
So 40
Again,
minus
ninth
10
grade
is-
boys basketball is dismissed at this time.
30
Thank
minus
you.
2x. Homework is just to finish the rest of the problems are wrong.
For that.
She's not necessary. All right, so to get the width, you might want to like draw an arrow. Like this is how we got it. Okay, so if you look back at your notes, you might not know where that came from. Okay. All right, so these are our dimensions. They want us to write a function that is the volume. So remember, volume is typically length times width times height. But instead of using height this time, the book for some reason is calling this the depth instead of height. So what we're going to do is we're going to substitute in the three things that we've defined to be the length. We will use parentheses around our binomials. Now you don't actually have to FOIL and distribute if you don't want to, because it didn't tell us it has to be in standard form, So it doesn't tell you, you can just leave it like this.
That's it?
It's part of it. Then they want us to find the x-intercepts and ask us what they represent. So you have two options to find the x-intercepts. You can either, option one is to use your graphing calculator. The other is to actually use the zero product property. Aubrey's on her way. So if you remember, the x-intercepts are when y is 0 or when volume is 0. So if you don't want to have to go in your calculator and do a bunch of work, you can actually just set each of these equal to 0. So this would be our zero product property. Let's see, that's from quadratics. So this would be x plus 10 equals 0. Subtract 10, we would get one of our x-intercepts is negative 10. This one we would have 30 minus 2x equals 0. I would probably add 2x to both sides personally, and then divide by 2. We'll get 15. And then the last one would just be x equals 0. Quite a few of you forgot when there's just an x that you still have to use the zero product property when we were in chapter 5. So the x-intercepts are those numbers. All right, and you can actually see them below because I put this picture on your notes. You can see our x-intercepts. What do they represent? Zeros, yes, of the function. But in terms of the word problem, what do they represent? What does x itself represent? Depth. Okay, so these are the values of the depth that would actually make the volume be 0, meaning that the luggage would have no volume to it. Okay. So if we were to plug in these numbers, we would actually get a volume that is 0, meaning you wouldn't be able to put any of your stuff inside the suitcase because there would be no space inside. Okay. So these are just bounds. Now they want us to describe a realistic domain. We know domain is our set of all x values. If it didn't say realistic, we would say negative infinity to positive infinity because of the arrows. But they say realistic because this is a word problem. Okay, so remember, x is representing the depth, and y is representing our volume. If you wanted to label the axes so that you can interpret the problem a little bit more. So what do you think a realistic domain would be for our x values? Again, normally it would be negative infinity to positive infinity, but in this case it won't be. Can we have a negative depth? No. 0 to 15. Would it include 0 and 15 or not?
No.
Not. If it, so we'd actually have to include like 0.001. So your two options would be to do parentheses 0, comma 15, parentheses. Do you remember how we did like brackets and parentheses? This is not inclusive. Okay, that's using interval notation. Or if you prefer, you could say 0 is less than x is less than 15. Those are the same things, whichever one you prefer. Remember how we used to say like negative infinity, comma 5 bracket? That's what this is looking like. Some of you will think this looks like an ordered pair though. So if you don't like it that way, you're welcome to write it like this, where the x values would be between 0 and 15, not including those values, because if they included it, the volume would be 0 and you wouldn't have a piece of luggage at all. It wouldn't actually exist. Now, part C asks us, what is the maximum possible volume and what are the corresponding dimensions? So looking at our feasible region, how would we find the maximum? Oh, you have it. It's the rest of the page. How do we find the maximum of this region? How did we utilize our graphing calculator to find the relative maximum? Abby?
Second trace.
Good. Where's for quadratics? All right, so we have to type this equation into our y equals. Again, you can type it in factored form. You do not have to FOIL it all out. So we had x plus 10, parentheses, 30 minus 2x, and just x. Now you can actually see they told you how to set your window so that it will fit, because if we press graph right now, I don't think it's going to be a very good picture, but let's see. Zoom 6. Yeah, really bad. So we can go change our window to match up with what they have here. So press window. And let's change our x min to be negative 15. Our x max to be 20. Our x scale, which means what they're counting by, they chose 5. All I'm doing is copying this right from your notes. The y min, they chose to be negative 1500. The y max, 2500. And the y scale, 500. And then do not press zoom 6 after you did all that work, just press graph. And hopefully if you did it right, it should look exactly like what you have on the paper. And then we can use our second trace, and Abby said we're going to choose maximum this time because we're looking for that max. So second trace, option 4 for max. Again, you're looking for this point up here, so you're going to be to the left of that, which is good, right where it's at for me. And then you have to go to the right of the max, so all the way to the other side, somewhere, and guess. Okay, now remember, y, our y-axis was the volume, so the maximum volume is 2052. And did they give us units on this? Inches. Does anyone know what the units are for volume? Inches cubed, or cubic inches. So how many cubes you could fit inside of the space. So that's part of our question. What are the corresponding dimensions? So go back to your graphing calculator. You need to know what x is. X is one of your dimensions. That's our depth, I believe. So x is 8.9. Let's see what I did. I think I may have just done 8.9. Why do I have 8.8? Did anyone get 8.8 on theirs? Okay, who knows? Should be 8.9. If you wanted to do 8.93, you could. And then all you have to do is plug that back in to get your dimensions. So the length would be x plus 10. So 8.9 plus 10 would be 18.9. And that's just regular units. Again, all you're doing, and I can't fit this on the board, is you're plugging this all back in up here. Okay? Your depth was just x, so that's just 8.9. And your width, you can calculate the width for me. 12.2. It's just fun. So easy. So easy. All right. So I'm gonna let you guys work on how much time we have? 1:54. I'm gonna let you work on the homework. I would at least try to come up with expressions for your length, width, and height and volume together with a partner. And when you're struggling, you can call me over and I can help you.